Good afternoon, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic magnetic field intensity, how it is being calculated using this Ampere's circuit law. So before starting with the discussion, let's discuss about this. Let's recall about the magnetic field intensity due to Biot-Savart law. So according to Biot-Savart law, the magnetic field intensity is directly proportional to the product of I and dl, which is nothing but current element, and inversely proportional to the square of distance. So this Biot-Savart law can be applied for calculating the magnetic field intensity due to the infinite straight conductor, and it is being used for circular loop, and also it is being used for calculating the magnetic field intensity of a solenoid. So in this discussion, we are going to discuss about this Ampere circuit law basic and how it has been used for calculating the magnetic field intensity and what is the real-time application involved over here. So before starting with this, let's discuss about the historical background behind this Ampere circuit law formulation. So in the year 1826, Ampere is one which has been formulated this Ampere circuit law, and this is by observing the electric current which produces the magnetic field. He observes how the electric current produces a magnetic field, and based on this observation, he formulated this Ampere's law in the year 1826. So, and this Ampere's law forms a basic for Maxwell equation, and also it is a foundation for the modern electrical engineering and electromagnetic theory. So what is the statement behind this Ampere circuit law? So according to Ampere circuit law, the line integral of magnetic field intensity over any closed path is equal to the current enclosed by that path. So here the expression is given as integral over closed path H vector dot dl is equal to I enclosed, where H is a magnetic field intensity, I is a current that is enclosed by that particular path. For visualization point of view, we are considering a magnetic field around a conductor. So when a current flows through a straight conductor, concentric circular magnetic fields of lines will be created around it. So the current carrying conductor produces a magnetic field. When current flows through a conductor, concentric circular magnetic field will be created around the conductor. And the distances decreases. The field intensity is based on the distance, and the distance will be decreases, or field intensity will be decreases based on the distances. So what are all the applications of this Ampere's law? It has been used in solenoid for calculating the uniform magnetic field, and toroids it has been used for determining the field distribution, and coaxial cable it is used for analyzing the field confinement between the inner and the outer conductor for signal transmission, and for transmission lines it is used for understanding the patterns between the conductors. And what is a prototype behind this Ampere circuit law? First thing is that we have to determine the symmetry. We have to determine if the geometry exhibits a cylindrical, planar or spherical symmetry. Second one is that we have to choose the Amperian path. Select a closed loop where magnetic field is constant or zero. Third one, we have to apply the integration. Evaluate line integral and equate to the enclosed current to solve for the field magnitude. So through this Ampere's law, it quantifies the relationship between the current and the induced magnetic field circulation, and this integral form enables a calculation of magnetic field in symmetric configuration effectively. It is a foundation for designing the electromagnets, transformers, motors and communication systems. One of the four Maxwell equations describes all the classical electromagnetic phenomena, and the Maxwell equation foundation is given by this Ampere's law. So far, we have discussed about the Ampere's law. We have discussed about what is the statement behind this Ampere's law. And before that, we had a recap of magnetic field intensity due to Biot-Savart law. And later, we have discussed about what is the statement behind this Ampere's law. And we have seen the expression for this Ampere's law. And what is an historical background behind this Ampere's law. And what are all the magnetic field characteristics. So for this, when a current flows to the conductor, it will be producing the concentric magnetic field and decreases with the distances, and the direction follows a current flow direction. and we have discussed about the key applications of the Ampere's law, where it has been used. It is used in solenoids and all, and it is used in cables for determining the communication path. And what are all the problem solving strategies? First, we have to identify the planar, and we have to choose the Amperian path, and finally we have to apply the integration. And finally we have discussed about the key concept involved over here. Thank you.